Okay, this is number 13 on 7.2. Kind of working a little bit late here, so I've got to get going. So what I'm going to try to do is use a sketch. This is a sketch that's in the book, so you can refer to it. But we want to find the area enclosed by these two curves. Again, this is the top curve, y equals minus x squared plus 3x. And I should say it's the top curve here, but it's the bottom curve there. And this curve also fluctuates, so this is y equals 2x cubed minus x squared minus 5x. So this is the top curve here, and it's the bottom curve there. So when we set up our integrals, we have to be careful, and we have to do two integrals. Okay, and they intersect, and I think that was pretty much apparent from the graph that they intersect here at 0 and at negative 2, x equals negative 2, and x equals 2. So we're going to integrate okay, using this as the top curve minus the bottom curve from negative 2 to 0, and then from here we'll flip it, and now this is going to be the top curve, and that'll be the bottom curve from 0 to 2. That's what we've got. It's a little hard to see that, so I'll write it over here. So again, this is number 13. 7.2. See what's going on here. So you saw we set that up, and again you can refer to your sketch in the book. So it's going to be either go from negative 2 to 0, and this one 2x cubed minus x squared minus 5x. That's going to be the top curve. Okay, minus the negative x squared plus 3x. That's going to be the bottom curve, and that's all with respect to x, plus the integral from 0 to 2, and then I flip them, so this negative x squared plus 3x will be the top curve, minus the 2x cubed minus x squared minus 5x will be the bottom curve. So we kind of flip like that. I think we had one of those in that practice problem we did off the APA release questions. Now we can simplify both these, so area equals, so my negative 2 to 0 will simplify. I've got the 2x cubed, but a negative x and a negative times a negative is a positive x squared, so a negative x squared plus x squared, they cancel. And 5x and, negative 5x and negative 3x becomes negative 5x. Negative 8x dx. And then this integral from 0 to 2 simplifies, and I got a negative 2x cubed. And then again, a negative x squared and a negative times a negative is positive x squared cancel out. And then I've got 3 negative times the negative is a positive 5x, so I get plus 8x. So see, they simplify real fast. So it looks pretty ugly, but it gets easier right away. Then we can just take the antiderivative, so this area equals. And again, we like to do these, analytically. So this is going to be 2x cubed over 2x to the 4th over 4 minus 8x squared over 2. And that's going to go from negative 2 to 0. Although the zeros go 0 out, so that'll be easy to do. And that's going to be plus over here, negative 2x to the 4th over 4, plus 8x squared over 2. And that's going from 0 to 2. Okay. Then we substitute in, we get area equals, and that cancels. If I put a 0 in here, this becomes 0 minus 0, so that's just 0. That's nice. Minus when I put negative 2 in. If I put negative 2 in here, that's still going to be positive because it's to the 4th power, so that's going to be 16 32 divided by 4 is 8, minus, that's going to be 4, and then 2 goes in 8 4 times, and negative 2 squared is 4, so 4 times 4 is 16. Plus over here, and then if I put 2 in, that's going to be 16 over 4 is 4, I'm sorry, 16 over 4 is 4, negative 2 times 4 is negative 8. Plus, and if I put 2 in here, 2, that's going to be 2 goes in 8 4 times, and 4 times 4 is 16. Minus, and then if I put the 0 in, that's just going to be 0. So that ends up being not so bad. Area equals, and that's going to be 0, that's going to be negative 16, well, the negative times a negative, so it's going to be negative 8. Well, I can make this negative 8 times a negative is a positive 8. And this is going to be 16 minus 8, which is 8, so the answer is just 16. So that wasn't too bad. But make sure you draw a sketch so you kind of have that in reference.